Okay, today's lesson is solving simultaneous linear and quadratic equations. So as you can see on the diagram, we can see that it's when we have a parabola, so that's the quadratic, and the red line is the linear. And just down here below, we've got three scenarios. So you could have it when your linear line crosses twice at 2 points, or you could have it where the linear line only crosses at the one spot. Okay, when the line only crosses at the one spot here, that red line or the linear line is known as a tangent. So when it only crosses, so it's a tangent to the parabola. So when it just touches at one spot. And also obviously the last scenario where we could have it for no point, so it never crosses either one of them. So that could be what happens. So when we solve them, we need, up here we can see we need all our equations to be y equals, so you may have to rearrange it so that you've got both of them y equals, and we'll see that in our next examples. So to find the points of intersection of the line with the equation y equals negative 2x plus 4 and the parabola with the equation y equals x squared minus 8x plus 12. Okay, so our two equation, here's our linear one, the minus 2x plus 4, and over here is our quadratic equation. So to solve that, we make sure they're both in y equals, so we let each equation equal each other. So I've got negative 2x plus 4 equals x squared minus 8x plus 12. So we're going to solve this equation. So because we have a quadratic really in there, we're going to solve it like a quadratic equation. So first I'm going to move these over the equal sign. So I will have 0 because I'm going to move both of them. I've got x squared, I didn't move that, minus 8x. The negative 2x becomes a plus 2x. The plus 4 becomes minus 4 plus 12. So if I tidy that up, I've got x squared minus 6x plus 8 equals 0. So this is a quadratic equation. So it's not one of the patterns. So I'll solve it using maybe the cross method. So factors of positive 8. So if I say negative 2 and negative 4, that gives negative 2x, negative 4x. That gives me, adds to give me that. So I've got the factors now. X minus 2, x minus 4 equals 0. So therefore I could say x equals 2 or x equals 4. So if we were thinking of the graph, so the quadratic, it's a positive quadratic, so it might have did something like this. So it crossed, see here, that crossed at 12, and then you had the linear line, and we know it's crossed at 2 places. Let's say like that. So we know it crossed at x equals 2 and also at x equals 4. So because we need to know the points, so we know the point x is 4, but we need the y value, and we know that is 2, so 4. So you can use any of the equations to sub in. So we're going to sub this into an equation to get the y value. So if we do that, when x equals 2, I'm going to use the linear because it's easier. So negative 2 times 2 plus 4. So y equals 0. So 1 point is 2, 0. So my graph's a little bit off. Should be crossing here. So 2, 0. And I'll sub in the other one. When x equals 4, we have y equals negative 2 times 4 plus 4. So that would be negative 8, so negative 4. So we end up with y equals negative 4, so 4 and negative 4 is the other point, so over here. There's the point. So we've solved the two equations and we've found the points. You could have subbed in using this equation and you still would have got the same number. Okay, so prove that the straight line with equation y equals 1 minus x meets the parabola with the equation y equals x squared minus 3x plus 2 only once. So we are going to let the equations equal each other. So this time I'm putting the quadratic first, and I'm going to say it equals the linear one, and I'm going to bring everything onto the other side, so the plus x, and I've got plus 2 minus 1 equals 0. So I've moved these two that way. Okay, so fixing that up, we've got x squared minus 2x plus 1 equals 0. Okay, so if you have a look, 1 squared is, so this is a pattern, because we could write this as x squared minus 2x plus 1 squared, and the middle term is 2 of them. So that factorizes to x minus 1 squared equals 0. So if you solve that, you only get x equals 1. So there's our 1 time. So if you're thinking about the parabola, so it looks maybe, so it's going to go down, and when it only crosses, might cross once, and we might have the green line, and we see that it comes down here. Oh, sorry. It comes down and it might cross just that once, and we'll say at the x is 1. Okay, and if you had to find out the y value, we'd sub that in, y equals 1 minus 1, so that's using x equals 1. We get y equals 0, so there's our point. So that's where it meets. So once again, that's called a tangent, that green line, tangent to the parabola. Okay, the next one, find the value of c such that y equals x plus c is a tangent to the parabola y equals x squared minus x minus 12. So what that means is that we're only going to have one solution, like the example above. Okay, so because it's only going to touch once, that's the new quadratic equation that we get from when we solve them simultaneously at the start. So the first thing we need to do is let them equal each other. So if I wrote the quadratic out, and I'll let it equal the other one, okay, and then we bring everything onto the other side. So x squared minus x minus another x minus 12 minus c equals 0. So I end up with x squared minus 2x minus 12 minus c equals 0. Now, because we know it only has one, so this only has one solution, because it's only going to touch their axes once, that means we know that the discriminant, which would b squared minus 4ac, is equal to 0. So let's work out the discriminant of this. So a is going to be 1, b is negative 2, and c is actually negative 12 minus c. So if we put that into our discriminant formula, discriminant will equal negative 2 squared minus 4 times 1 times negative 12 minus c. Okay, so that ends up being 4 minus 48 plus 4c, okay, which equals, sorry, that should have been plus 48, so that equals 52 class for C. So that's what the discriminant is, but we're going to let that equal 0 because we only have one answer. And then you rearrange, so get 4c equals negative 52, c equals negative 52 divided by 4. So c equals negative 13. So your answer for this is for what value of c? So when c equals negative 13. So the answer is when c equals negative 13.